This tutorial will help you to prepare for the group project you'll be doing in lab on fermentation. Fermentation involves a yeast. The yeast we'll be using is known as baker's yeast or bread yeast, and its name is Saccharomyces cerevisiae. Saccaro means sweet, myces means yeast or fungus, and cerevisiae means baker. Saccharomyces cerevisiae uses carbohydrates and in the process makes fermentation or undergoes fermentation. And fermentation is a process that you have learned about in lecture. Alcoholic fermentation produces alcohol, ethyl alcohol, and carbon dioxide. For this project, we're going to be measuring the amount of carbon dioxide that is being produced. Before you begin your preparation, read the lab exercise. After you read the lab exercise, look at the tables and you'll be able to come up with some research questions. I'd like you to please think of 2 research questions and bring them to class on the day that I tell you to. You'll be turning in a copy of your questions at the start of class, so I know you've done the work. So make 2 copies, put your name on both of them. During class, you'll break out into your lab group and you'll discuss your 2 research questions with every member of the group. After discussing your questions and everybody else's questions, along with me coming in and weighing in, you'll decide on a question that you want to research. Try to make it so that everybody in the lab is doing something different. So you may have a research question you've decided to test, but somebody else, another group, has already picked that question and has the same product, so we're going to put you down another path. You're going to compare at least 3 products and no more than 5 in your experiment. You're also going to have a control. We'll be using a heating pad, and the heating pad only has enough space to put 6 baggies on. So up to 5 products is fine, no less than 3, please. There has to be sound reasoning for the products that you choose. You can't just choose 3 products from the list and say, these are the 3 we're going to test. You're going to derive a hypothesis after your research question, so there has to be sound reasoning for the products that you are testing. An important note, if you miss class and miss the planning of the experiment, you will earn only 50% of the points for the presentation. If you miss lab and don't help with the experiment, you can't participate in the group presentation and you will earn no points on this assignment. All right, so when you take a look in your lab manual, you'll see there are 3 tables, and I'll be providing you a 4th table. So this first table shows you natural caloric sweeteners. Natural means they come from some plant source or perhaps honey from bees. So you can see as you look down here on the list that fructose is found in fruit. We normally find fructose in fruit, but it also can be made commercially from corn. Glucose is made from the hydrolysis of cornstarch, but it's also found naturally in nature. We have maple syrup that comes from maple tree sap. So you're going to take a look at these columns and start to look for similarities and differences. First, look at the composition. The composition column shows you the composition of these sweeteners. So sucrose is a disaccharide. You've learned this in lecture already. It's made of glucose and fructose. Glucose is just a monosaccharide, and so is fructose. Now look at molasses. Molasses has sucrose, glucose, and fructose in it. So half of it is actually disaccharides, and the other half are monosaccharides. Okay. We look at agave. Agave is 50% fructose and 20% glucose, and you can see that both fructose and glucose are monosaccharides. So as we look down the list, we can see that there are a lot of different combinations here. You also see that yacon syrup, which comes from a tuberous root of the yacon plant, has something in it called fructooligosaccharides. These are natural carbohydrates. They're composed of linear chains of 2 to 60 fructose units, terminating with a glucose molecule. So they're not metabolized in the small intestine like other carbohydrates are in humans. They reach the large intestine unchanged, where they're metabolized by bacteria. So they're considered to be a soluble dietary fiber. Right? Let's take a look at the next column, which is calories per gram. You can see there is a range of calories, with the highest being sucrose. Sucrose, glucose, and fructose all have the same number of calories per gram. So does coconut syrup and corn syrup. But then looking at yacon syrup, there's only 2 calories per gram. Maple syrup only has 2.5 calories per gram, so fewer calories there. Remember, calories are a measure of energy in food. Calories are essentially a human construct where we figure out, remember, by burning the food to figure out how many calories are in it. The next column is an interesting one. This is relative sweetness. Relative sweetness is a comparison of the sweetness of that material to sucrose or table sugar. So sucrose is given a relative sweetness of 100. If you look at glucose, then it's only 75% as sweet to humans as sucrose is. So remember that yeast don't have taste buds. So relative sweetness is something that humans use. If you're going to make an artificial sweetener, for example, you'll determine using a panel of humans to determine the relative sweetness. Because it's something that is strictly determined by humans, doesn't mean that you can't use relative sweetness as a basis for a hypothesis in your experiment. The last column you're seeing here is the availability for your experiment. So each of these tables will show you, is this a solid? Can you get this in a liquid form, or is it in a packet form? Solids have to be compared to solids, liquids to liquids. So as you are choosing your products to use, make sure they are all of one type. The second table here takes a look at sugar-free caloric sweeteners, right? So these sweeteners have calories in them, but they do not have sugar as per se. They are sugar alcohols. So these are commonly used for diabetics because they don't have impact on blood sugar like other carbohydrates, sucrose, fructose, or glucose would have. One of the problems with sugar alcohols is they draw water out of the intestines, and therefore they can cause diarrhea if you use them in large quantities. But you can see that they are all natural, just like the previous table. So we've got mannitol that comes from pineapples or olives, sorbitol comes from fruits and vegetables, erythritol comes from fruit and fermented foods. You can also see that the calories per gram is significantly less than sugar. So we've got 4 for sucrose compared to 1.6 for mannitol. You can also see that for most of these, with the exception of xylitol, they are not as sweet as sugar. So often they are bulked with another material to make them sugar. There's some interesting information in the other column, and it tells us about causing a laxative effect. You can see that all of these come in a solid form. Erythritol comes in a packet form. So as you're looking at this table, you should be seeing some similarities and some differences between Table 1 and Table 2. You should start now to think about some questions. Which of these products might yeast preferentially use in fermentation? Which one would give more fermentation, more carbon dioxide production? Which one do you think would be less? Taking a look at source, calories per gram, or relative sweetness. The third table is non-caloric sweeteners. Some of them here on the list are natural and others are not. So stevia and monk fruit are non-caloric sweeteners. They have no calories. They have a great relative sweetness, 3 times actually, a relative sweetness of 300 compared to sucrose. So you need much less of this. Many people find that stevia and monk fruit have somewhat of a bitter taste, but they are natural. And then we look at the last 4 on the list: sucralose, saccharin, aspartame, and ACE-K. Those 4 are chemically manufactured. They are not natural products. So again, here we see some differences, natural and chemical. Stevia and monk fruit, as well as all of these others, are very often combined with a bulking agent. So if you get the little packets, for example, and it says the packet has sucralose in it. Sucralose is known as Splenda. And you see the packets, The packets have very, very little Splenda in them, actually. So you would probably open the package and say, hey, I've been ripped off. There's nothing in this package. So they have to put something in there with it in order to give you the feeling that there's something in there. What they typically put in there is called a bulking agent, and it is maltodextrin. Maltodextrin actually has some calories. So be aware that if you choose packets in your experiment, that you are not using the pure product, but you have these bulking agents in them. I do have the pure product available to you, so I do have sucralose as a solid all by itself that isn't bulked. I have saccharin all by itself, aspartame all by itself, and ACE-K. So if you're trying to compare a non-caloric versus a caloric sweetener, I would suggest using, rather than the packets, using the solid product. The last table is a little bit different. Here we have some polysaccharides, and you can see these are very complicated. Flour, for example. Yeast uses flour when bread is made, so there's no reason not to try flour. This is a composition of starch. Starch is made of amylose and amylopectin. Then there's also some protein in there. Protein is not fermentable by yeast, but there's some glucose as well in flour. Okay. And there's some information here about glutens. You might be interested, especially if you have been diagnosed as being glucose sensitive or gluten sensitive. Soy flour is a little bit different, has a lot more protein in it, and it has a variety of sugars in it. Then there's potato starch. Potato starch has amylose and amylopectin, just like the starch in all-purpose flour. Pectin is a soluble fiber. It has galacturonic acid. This is an oxidized form of galactose, which is a disaccharide. Then there's inulin, and the inulin is a prebiotic, also as pectin, a prebiotic. So these are not digested by humans, but they are metabolized by some bacteria. And then we have cellulose. And remember, cellulose is found in the walls of plants. Cellulose is consumed by humans to prevent constipation. So cellulose is often going to be found in preparations that prevent constipation. So again, you can see calories per gram on here, availability for your experiment, and some other interesting information about the products. So by now, after looking at all four tables, you are probably, I hope you are, thinking of some interesting products that you might like to test and why you want to test them, right? So your goals of your project are to compare products either or within tables or across the tables. Predict which products will produce more carbon dioxide in fermentation by yeast. Choose anywhere from 3 to 5 products and predict which one is going to produce the most gas in fermentation. Why do you think this is going to happen? That's your hypothesis. Hypothesize the reason for gas production in your comparison based on the information given in the tables and on your knowledge of carbohydrates. Then you will design and execute a controlled experiment. The design of the experiment is going to be accomplished in lecture so that when you get into lab, you will be ready to go with your experiment. Setting up the experiment, you're going to be given a Ziploc baggie, some duct tape, hot water, and yeast. You can find in your lab manual procedure for doing this. You're going to measure the product. So if you decide to use a liquid, you will use 1 teaspoon of each of the liquids. If you're going to use a gram, you'll use a balance to weigh out the solids in grams. And then if you're going to use a prepackaged sweetener, you will use a packet of each. You'll then put the water in the baggie, as you can see here in this image. So this group has 4 baggies here, and they are testing 3 products and a control. And you can see that the baggie has water in it, and it has the yeast. It also has the sweetener. Okay. We also are going to duct tape the baggies closed to make sure that they don't leak, and then we lay them on top of a heating pad. Don't forget that you have to have an experimental control for your experiment. Sometimes there are 2 controls in the experiment, depending upon what you are testing. As you are designing your experiment, make sure you think about what is going to be in your control baggies. Right? Here are some of the materials you're going to be using. After the hot water, products and yeast are added to the baggies. They're sealed and taped to prevent leaks. All baggies, including the controls, are going to be put on the hot pad. That's going to encourage fermentation, which proceeds faster at a warmer temperature. Fermentation will produce carbon dioxide, so the baggies are going to inflate. The more fermentation, the more gas, the larger the baggie will become. At first, you'll see a few bubbles developing inside the bags, and then the bags actually will become quite inflated. Periodically, and you'll decide the time period for this, you will measure the size of the bag. This is why you see the tape measure on the image. One way that you can measure gas production is by rolling up the bag. You'll have to do this, of course, at the very beginning of the experiment so that you get a measurement at time 0. Each bag is going to have a little bit different measurement of the girth. And do make sure that it is one person only that is measuring, perhaps one person measuring, another person helping. Just like with the enzyme experiment, you don't want to have two people trying to do something, make a measurement, because there's too much disagreement. So one person will make the measurement and write the results in a table. If you can come up with another way of measuring gas in the baggie, you certainly are welcome to do that. You want to take measurements at regular intervals for the lab period. It takes about 30 minutes to get everything set up. So once you have everything set up and on the heating pad, you can take measurements for an hour and a half. So every 10 minutes perhaps, or every 15 minutes, you want to take a measurement of the baggies. So get thinking.